Jai Shri Ram friends, today is lecture number 47. Welcome to all of you. Gravitation. Topics covered would be acceleration due to gravity, full detail with numerical problem. Let us start. Now, acceleration due to gravity on the surface of Earth. See, this is the diagram in which a body is there with weight mg, center at O. Okay, the radius of the Earth is capital R. Suppose then what we can say is small g is equal to gm upon r square, as we have already seen. Also, we have to remember that small g is equal to 4 by 3 pi capital G r into rho, where r is the radius and rho is the density. Now, see the derivation. Actually, as per this diagram, force of attraction between Earth and the body is nothing but F is equal to G m into m upon r square, right? So the force of gravity F produces an acceleration G in the body of mass M. So from Newton's second law, we can say F is equal to mg. Fine. So from equation number 1 and 2, we can see this G is equal to Gm upon r square. So this is how we can prove this expression. There is a small numerical. Just see this. A man can jump 1.5 meter high on the Earth. Calculate the approximate height he might be able to jump on the planet whose density is 1/4 that of the Earth and whose radius is 1/3 of the Earth's radius. Okay. So as per the requirement of the question, this is your solution. The actually acceleration due to gravity on the Earth's surface, this G is equal to 4 by 3 pi G r rho. Okay, equation 1. On the planet, it would be G dash 4 by 3 pi G r dash rho dash. So given in the question is rho dash is equal to 1/4 of rho. So you can say r dash, and r dash is also given as 1/3 of r. So from equation 2, we can say G dash is equal to 4 by 3 pi G 1 upon 3r into 1 upon 4 rho. So from equation 2 further, we can say G dash is equal to 1 by 12 of 4 by 3 pi G r rho. Means it means that G dash is equal to 1/12 of G. Okay, so assuming man puts the same energy, then mg, that is the potential energy, would be equal in both the cases. So mg is equal to m g dash h dash. So putting the values, okay, mass of the man remains same, and g value, g dash and h dash values are placed. So finally, you can say h dash is equal to 12 into 1.5, that is 18 meter. The final answer is 18 meter. Now next is variation of g due to altitude, means height. Okay, suppose at point A, that is the surface point, and B at some height is small h. Okay, then g at any height h is equal to g into r upon r plus h whole square. In general, you can say. Okay, now if h is very small as compared to r, then gh is equal to g 1 minus 2h upon r. This is binomial expansion. Okay, so this is the expression. You can drive also this expression. How to drive this? See, consider the Earth to be spherical surface or sphere of mass m, radius r, and center rho. Suppose then the acceleration due to the gravity at A on the surface of the Earth, that is small g, is equal to gm upon r square, right? So if gh is the acceleration due to the gravity at point B, write this one, at a height h from the Earth's surface, then gh is equal to g into capital M upon r plus h square. Okay, so you are if you are interested to calculate the value of this, the ratio means just divide equation 2 with 1. So you are getting gh upon g is equal to r square upon r plus h whole square, or you can say gh upon g is equal to this 1 plus h upon r ki power minus 2. So this is the relation. Now using this relation, we can further approximate. If h is very small as compared to r, then h upon r is very small as compared to 1. So expanding by binomial theorem and ignoring the higher orders. Okay, higher powers को neglect कर देंगे, तो you are getting final answer g is equal to g 1 minus 2h upon r. So this is how you can prove. Now certain important points which are to be remembered for in concern with the variation of g due to altitude. Number 1, the decrease in the value of g at height h is g minus gh, which is 2gh upon r, or you can say g minus gh proportional to h. Okay. Second point is the percentage decrease in the value of g at height h is nothing but g minus gh upon g into 100. So this is the percentage increase, that is 2h upon r. Third point, the loss in the weight of the body at height h is nothing but mg into mg at height h. So you can say 2m into g upon gh upon r. Okay. And fourth point is at any altitude h is equal to say 320 kilometers, gh is equal to 0.9 of g. That is the value of g decreases by 10%. You can calculate this percentage by using the formula and putting the value of h. Okay. And fifth point is a typical space shuttle altitude is h is equal to 400 kilometers. Okay. Now see one problem to illustrate the same concept. At what height from the surface of the Earth will the value of g be reduced by 36% from the value of at the surface? Radius of the Earth is 6400 kilometers. Now how to solve this? Suppose at height h, value of g reduces by 36%. Okay, that is, it becomes 64% of the value of the surface. So gh is equal to 64% of g, or 64 upon 100 into g. Now as per formula, gh is equal to g 1 plus r upon r plus h whole square. So putting the values, you are getting the expression like this, that is 64 upon 100 r upon r plus h whole square. Or if you are further solving this formula, and you are getting this answer as 1600 kilometers. So this is the final answer. Now derivation we shall see regarding the variation of g with respect to depth. Suppose this is the diagram and this is the surface, Earth surface. Okay, उससे अंदर d की हम depth में जा रहे हैं. Okay, so what is the radius of Earth? That is r, as given the O is the center. Okay, and at any depth d, there is another spherical surface which is at suppose this B point is on that particular surface. Then on the surface of Earth, g is equal to gm upon r square. We already know. So assuming Earth to be the homogeneous sphere of average density rho, then mass is nothing but volume into density. So you can say m is equal to 4 by 3 pi r cube into rho. So you can say g, small g is equal to g into 4 by 3 pi r cube rho upon r square. Means on the basis of proportionality, you can calculate the value of g. Means g is equal to 4 by 3 pi g r rho. That is equation 1. And let gd be the acceleration due to gravity at point P, as I am showing in the diagram. So according to Newton's shell theorem, which we have already studied, a body at B experience gravitational force due to inner sphere of radius r minus d and mass m dash. So you can finally say m dash is equal to 4 by 3 r minus d cube into rho, isn't it? So this is simple. So therefore we can say gd is equal to g m dash upon r d minus d whole square, or further we can write g upon r minus d square into 4 by 3 pi, and this value could be written as r minus d cube into rho. Now you can say this expression comes out to be gd is equal to g m dash upon r minus d whole square, or if you are solving this, so you are getting this equation 2, that is gd is equal to 4 by 3 pi into g into r minus d rho. Okay, this is an important thing. Okay, so you are, if you divide this equation 2 with the equation 1, okay, so you can say gd is equal to g into 1 minus d upon r. So this is the proof of the particular expression. Next topic is weight of a body at the center of the earth. Suppose again, if you are considering the same diagram, then at the center of earth means d is equal to r, right? So formula becomes gd is equal to g 1 minus d upon r. So putting the values, you are getting gd is equal to g 1 minus r upon r, means the answer is 0. So weight of the body at center of earth, that is w is equal to m into gd, that is m into 0. तो यहाँ पर center पे उसका weight 0 हो जाएगा. Okay, w is equal to 0 at the center of earth. Okay, now certain important points regarding the g with depth. First point is the acceleration due to gravity decreases both with the increase in the height and increase in depth. So it is maximum at the surface of the earth and 0 at the center of the earth. Second important point is decrease in the value of g at the depth d is g minus gd is equal to d upon r into g. Okay. Third important point, we have already seen percentage decrease in the value of g at depth d is equal to g minus gd upon g into 100, that is d upon r into 100%. Okay. Now relationship between the height h and depth d of for the same change in g. So this is one thing which should be remembered, that is gh is equal to g 1 minus 2h upon r, already seen. Gd at any depth d is equal to g 1 minus d upon r. Okay, these two expressions we have already seen. Now for same change in g, that is gh is equal to gd, so what should be the relation? So you are just equating the two equation, 1 minus 2h upon r, that is equal to 1 minus d upon r. So 2h is equal to d, or you can say d is equal to 2h, means only when h is very small as compared to r. Okay, now see one question, one numerical problem. Find the percentage decrease in the weight of a body when taken 16 km below the surface of the earth. Take radius of the earth as 6400 km. Now see this one, how to solve this problem. Here r is given as 6400 km, d is equal to 16 km. Now using the formula gd is equal to g 1 minus d upon r, that is also equal to g 1 minus 16 upon 6400. Putting the values, we are getting 399 upon 400 into g, or you can say g minus gd is equal to g minus 399 upon 400 into g, or 1 upon 400 g. So percentage decrease in weight is nothing but this mg minus m into g at depth d divided by m into g into 100. So if you are solving this and putting the values,